Welcome students. Myself Dr. Monika Khetarpal. In my previous lectures of classical mechanics of MSc previous physics, I have discussed about central force problem. In the central force problem, we have derived the three Kepler law of motion. On the basis of these Kepler law, we are going to discuss examples. So, first of all, before starting the examples, I am giving a brief review of Kepler law. Kepler stated that there are three laws. The first law states that planets move in ellipse with sun at one of foci. And the second law is dA by dt equal to constant. That is, the area swept by radius vector in equal times are equal. And the third law, t square directly proportional to a cube. That means square of time period of revolution, it is directly proportional to the cube of semi-major axis. These are the Kepler laws. And we have also discussed the condition of eccentricity, that if eccentricity epsilon is less than 1, then in this condition only we will have elliptical orbits. So, on this basis, the first example is we are given a charged particle which is moving under the influence of a point nucleus. Find the orbit of the particle. That means we have to determine the condition, the shape of the orbit, whether it will be hyperbola, parabola or elliptical. And we know that the deciding factor is eccentricity. If epsilon eccentricity is greater than 1, then it will be hyperbola, and if it is equal to 1, it will be parabola, and in the condition of epsilon less than 1, it will be ellipse. So first of all, we have to determine the value of eccentricity. In order to determine this, initially we have to find the force acting on the charged particle. For this purpose, I am taking that let Z is the atomic number of nucleus and E be the charge on electron. Then the force acting between nucleus and electron, it will be minus 1 upon 4 pi Z square upon R. Z square upon R square. This is the force acting between the nucleus and the electron. Here we have a factor which is constant, and it is Z square upon 4 pi epsilon 0. Now we know that eccentricity can be expressed in terms of total energy E, and the formula that we have derived in our previous lectures for eccentricity is epsilon equal to under root 1 plus 2E L square upon mk square. So, substituting the value of k, 1 plus 2E L square upon m, and the value of k we have determined as Z square upon 4 pi epsilon 0. This whole square. Now, we know that total energy is related to the semi-major axis, and it has a formula E is minus k upon 2a. So we have the value of k as z square upon 4 pi epsilon 0. My E will be minus z square upon 4 pi epsilon 0 multiplied by 1 upon 2a. Using this value of total energy, my formula for eccentricity can be simplified to a form epsilon equal to under root 1 minus 4 pi epsilon 0 L square divided by a m z square. From here we can say that value of epsilon, it will be less than 1. 1 minus the factor, all this factor which is a constant factor, it will make the value of eccentricity to be less than 1. And as I have already stated that this situation corresponds to the condition of elliptical orbit. Hence we can conclude from our calculation that path of electron which is moving under the influence of a nucleus, it is elliptical in shape. Now with this I am moving over to the next problem. The next problem is of a particle which is moving in an elliptical path with velocity v, and we are given that this particle is moving in an inverse field. So we have to determine the value of velocity square and prove that it is k by m multiplied by 2 by r minus 1 upon a. Here all these factors k and m, these are constant, and a is the semi-major axis of elliptical orbit. So in order to solve my problem, I am assuming that this particle which is moving with velocity v, it is moving in the elliptical path under the influence of square law of force, and we have energy minus k upon 2a, a being the semi-major axis, and we know that E is the total energy, and total energy means, according to the conservation laws, kinetic energy plus the potential energy. Hence from this we can determine the value of V square by the help of kinetic energy. The kinetic energy T will be E minus V, and in our problem we are given that the particle is moving in an inverse field. That means force is minus k by r square, and from force we can obtain the potential energy which is V equal to minus integral F dot dr. So V comes out to be minus k by r. Using this value of V and total energy as minus k by 2a, kinetic energy as half mv square, I get, on simplifying, the value of V square to be as 2k by m multiplied by 1 by r minus 1 upon 2a. And this expression on further solving can be reduced to an expression which is given in our problem. So using an elliptical motion for a particle under inverse square law of force, we have derived that V square is k by m multiplied by 2 by r minus 1 upon a. So these are very important problems for the clear understanding of central force problem. Thank you students for watching.